Hello everybody. Today what we're going to be looking at is something called relative frequency when it comes to probability. Now, what relative frequency means is the more times that you do an experiment, just like in science, the more accurate it becomes. Show you what I mean with this question. Here we've got somebody throwing darts in batches of 10, and we're counting how many times they hit the bullseye, which is the middle piece of this dartboard. First batch of 10 hits the bullseye 4 times. Second batch hits 8 times. The third, 3, and so on, 3 and 2 there. So as you can see, the results go up and down. It's only by doing these 5 batches, or possibly even more and more and more, that you can get an accurate sort of prediction about what the average score of hitting the bullseye would be for that particular person. So if we were to consider the first batch of 10 there and talk about how we work out this relative frequency. First batch, bullseye was hit 4 times out of 10 throws. So the relative frequency then, as you fall as your 10 in this lower table, is 4 out of 10 as a fraction. And as a decimal, 4 out of 10 you can use on a calculator or work it out, is 0.4. Okay, in the second batch though, it wasn't 4 again, it was a slightly different story. So now, if you link these two together, the total number of throws is actually going to be 10 plus 10, which is 20. So you're measuring the performance not only in isolated groups of 10, but you're measuring it as we're going along. And therefore, the number of times the bullseye was hit was 4 plus 8, and this is where this 12 comes from. That 12 comes from that 4 plus the 8. There, I'll make a little note of it. And the 20, because you've got the 10 plus the 10. Okay, so your relative frequency will be 12, successful 12 bullseyes out of 20, which is the total. And if you were to work it out as a decimal, you get 0.6. Getting the hang of it, so we can carry on working out this relative frequency table now. Total number of throws, third group of 10, he's thrown that dart 30 times. And now how many times does he hit the bullseye? So we've got the 4 and the 8, which is a 12, and we add this 3 to it to make a total now of 15. So relative frequency, see, is going to be the 15 on the top of the fraction divided by the 30, which is the total number of throws that have been made. So 15 divided by 30, and as a decimal, well, that's a half, isn't it? So the decimal is 0.5. The fourth throw then, let's just do a couple more, so we've got fourth and fifth batch, is going to be 40 altogether. That's where we get the 40, 10, 20, 30, 40. Add another 3 to that 15 now to get 18. So we've got 18 out of 40, and you can either do it manually or with a calculator. It would give you a relative frequency of 0.45. And then the final one then, 50, because we've got 10, 20, 30, 40, 50 there. That's where the 50 comes from. Add the 2 to the 18, because all of these numbers will now add up to 20 now. Then won't they? So 20 adding up as we're going along. Relative frequency, 20 out of 50. And as a decimal, that will come out to be 0.4. So you could keep carrying on going, and the more accurate result will be if you just keep going and going and going. But for this table, and they'll always ask you this in the question, which sort of set of results will give you the most accurate? Well, it's always going to be the one with the most throws, because you've repeated the experiment more times and your result is therefore reliable. So that's how you work out relative frequency. One other thing that you might be asked to do is actually to plot the results in the graph. So remember, relative frequency will always range from 0 to 1. Okay, so if you haven't got the axes or the scale drawn in for you, choose a sensible one, making sure you've got 1 at the top and do your divisions. Here they divide it to 0.2, 0.4, 0.6, 0.8 and so on. So all we do now, after 10 throws, we've got 0.4, so we put a little cross there. Then 0.6 for 20 throws, 0.5 for 30 throws, 0.45 between the 2 there for 40, and back to 0.4 for 50. And then with a straight edge here, just join the points up together, and that will give you your relative frequency graph. So that is how introduction on how you to work out a relative frequency when you're given these multiple batches of data.